Hello everyone, welcome to today's video, and in this video we're going to be looking at the properties of a group and how to prove them using uh, the equilateral triangle, which is a dihedral group D3. Now first we're going to look at the closure property. So the closure property, what does that say? Remember, the closure property says that for every element in the set A, B in the group, the result of A and B is also in the set, right? So we defined our set R equals R, R2, and R3. We did this in the previous video. R means if you take a triangle and you rotate it by 120 degrees. R2 means if you take a triangle and you rotate it by 240 degrees. R3 means if you take a triangle and you rotate it by 360 degrees. So we're going to prove this property up here. That is the closure property, which says that if you do any composition of these groups, you would always get an element in the set. So that means if I do R composed of R, that will be equal to what? What would it be equal to? It must be equal to one of these elements. So it is closed. So R composed with R must be equal to one of that element. That is what the closure property means. Right? So let's do R composed with R. What does that mean? Well, to do R composed with R, I'll first of all do this one here. Let's do that R. So what you do is you do R composed with R, acting on the triangle. 1, 2, 3. Right now, let's do the rotation first. This rotation. So rotate, remember it's a 120 degrees rotation. So that will be equal to what? So you take 1, you move it down, take 2, move it to position 3, and then take 3, move it up there. We've done the first rotation. Now let's do the second rotation. So the second rotation, you take 2, you move it up there. So you would have 2 will go up there, 3 will go down, and then 1 will go there. So this is what you would have. This is R composed with R. So which of the elements in the set gives this type of triangle? It is the triangle, it is the element R2 acting on the triangle. So let's start with the initial triangle. The initial triangle is this one, 1, 2, and 3. So 1, 2, 3. That's the initial triangle. So R2, remember, means rotate the triangle twice or do a 240 degrees rotation. So that means you take this one, you move it 2 times, 1, 2. So you have a triangle that looks like this. The triangle 1, 2. So 1 will take position 3. And then you take this 3, you move it 1, 2, 1, 2. 3 will take position 2. And then you take this 2, you move it 2 spaces. So 1, 2. 2 will take position 1. Look at that. They look exactly the same. So that means R composed with R is equal to R2. Right? You can see that you can see clearly from everything that we've done that R composed with R is equal to R2. So if you take R and you compose it with itself, you will get R2. It is in the set. That means it is closed. The closure property is satisfied. You can test it for R composed with R squared. Let's do R composed with R squared. So you take this element r and you compose it with r squared. That will be equal to what? Again, you take r squared, and then act it on a triangle. 1, 2, 3. R squared here means rotate the triangle twice, right? So let's rotate the triangle twice. You take this one, you move it 1, 2. So that will be equal to 1, you move it 1, 2. So the 1 will be here. You take the 3, you move it 1, 2. So the 3 will be here. And then you take the 2, you move it 1, 2. So the 2 will be there. So we've done r squared. We've rotated the triangle twice. Or we've done a 240 degrees rotation. Next, you will rotate 120 degrees. That's rotate once. So that will be equal to, you take the 2. Let me draw the triangle first. You take the 2, you rotate it once. So you have 2 there. Take 3, move it there. And then you take 1, move it up. Like that. So which of these triangles look like that? Well, if you do R3, acting on the triangle, this is the triangle that we started with, isn't it? 1, 2, and 3. This is the triangle that we started with. So if you take, we're doing R3, rotate 3 times. So if we take this one, we rotate it 1, 2, 3. Notice 1 goes back to the starting position, which is what we have here. What if you do 2? Rotate it 3 times. 1, 2, 3. It comes back to where it started. And then if you do 3, 1, 2, 3, it comes back to where it started. And this is why we say R3 is the identity element. It gives you back what you started with. So R2 composed of R composed with R2 would give you the identity element R3. It's still in the group. Closure property is satisfied. So I'm going to give you an exercise to try. This exercise is difficult. Let me just do this one. I'm just going to do it. Well, you can pause the video and try to do it yourself. Just try it, and then when you're done, you can look at the solution. Okay, so we're going to do r squared composed with r squared. You might be tempted to say r squared composed with r squared is r raised to the power 4. Oh, this property is not satisfied, and therefore this is not a group because r4 is not in the set, right? But no, that is wrong. R4 is not what your answer would be. You can break it down like this. This is R4. R4 is same as R to the third multiplied times R, isn't it? But remember, we said R3 is the identity element. So that is the identity element composed with R. Remember, when you do the identity element composed with R, what do you have? You would still have R. So that means R is also in the set. You can prove this by doing decomposition. So R squared composed with R squared. What does that equal? Well, let's do R squared composed with R squared acting on the triangle 1, 2, 3. So first, you have to rotate this triangle twice. What would you have? 1 would move 2 spaces. You have 1 there. 3 would move 2 spaces. You would have 3 there. And then 2 would also move 2 spaces. You would have 2 up there. Next, you rotate again twice. So 1 would come here. 3 would come here. And then 2 would come here. So this is the triangle that we started with, right? This triangle right here, that's what we started with. If we do R acting on the triangle, are we going to get this? Let's find out. So take this one, move it down there. Take this 2, move it to the right. Take the 3, move it up there. Do they look the same? Yes, they look exactly the same. So that means r squared composed with r squared would give you r, and r is in the set. This property is satisfied, so it satisfies the closure property. In the next video, we're going to explore some of the other properties, the identity and the inverse. Thank you very much for watching. I'll see you in the next one. Bye bye.